Welcome back, everybody. This is our last video on 15.6. I know we've got a lot of physics students and engineering students in here. And so it's kind of good to know where comes in. Fluxes shows up in a lot of things. And it's not just fluids. We do things with fluids. It helps our equations for figuring out how airplanes fly and all sorts of stuff. When we're looking at fluids, though, or things besides fluids, we have other things that have flow that are not like liquid or gases, like the electric field E. If we do E dot N ds, it's called the electric flux of E. And you'll have seen some of this before in physics. Gauss's law talks about the net charge enclosed by a closed surface is Q, where Q is E naught times the surface integral of E dot N ds, where E naught has a value in Coulomb squared per Newton meter squared. It's called the permittivity of free space. That's not just the only example of a flux. We have heat flow, temperature. So the heat flow is going to be negative K times the gradient of T, where T is the temperature at XYZ. K is the conductivity of the substance that it has been determined experimentally, depending on the substance. So the rate of heat flow, F dot NDS, is negative K gradient of T dot NDS. So we have things in physics that show up where this kind of stuff shows up. That's just some elementary physics that you'll have learned at community college. Dig down the rabbit hole in physics or applied mathematics or the right forms of engineering, and you'll get to see a lot more of this stuff. It's actually really fascinating. That's it for 15.6. Peace.